Hi, everybody. Dr. Charlton here again. Today I'm going to kind of give you a jump start in R. As you can see here, I have R Studio Cloud. You can see the logo up in the upper left, and this is what I'm going to be using. Typically, you can use R in a lot of different ways. You can install R on your desktop for free. So you can download it right now and install it on your Mac or Windows or Linux machine for free and run it locally. I like to run R on a server. So I use, if you're familiar with Amazon Web Services, Amazon has server space that most of the big companies in the world use to like host their websites and to do all their heavy data analysis. I use Amazon Web Services mainly because then I can access it from any machine, whether I'm at home or at work or wherever I might be, at whatever machine I'm on. I can just pull it up in my browser, which I really like. And so it gives me incredible flexibility when I'm doing my data analysis. I can do it anywhere and pick up where I left off on any machine. So I really like that. I'm very much someone who really likes cloud-based software because then, like I said, get to it from anywhere. This is RStudio Cloud. So this is like a free kind of training wheels version for people who just want to practice R and kind of get to know it a little bit. And it is full featured, but it probably may not have the computing capacity of your personal desktop machine. So it might be a little limited there, but for our purposes, it should work really, really well. The advantage of our Studio Cloud is that we can share work and collaborate on things. So I can share like a homework out to you, and you can work on that and do it, on your own time. But it just gives a way to kind of access that, which is great. All right, so I'm going to go ahead and dive in right here and show you how to do a regression. This is going to seem familiar because I've actually already showed you this earlier in the semester, kind of gave you a sneak peek of this. And I'm going to be doing pretty similar analysis to what I did before. So first of all, I want to see what data sets I have. So there are some built-in data sets in R, and I'm going to pull up the list of those right now so that you can see. So they're just toy data sets, right? So you can play around with them, practice regression. We're going to make heavy use of these toy data sets over the next couple weeks as we kind of dive in and learn about statistics. And this is going to lead up to our final project where we have this survey that we're putting together. We're going to need to analyze our data that we get back from it. We're going to use regression and other statistical techniques for that, and we're going to do that in R. So I'm going to show you how to do that. So first of all, let's see what data sets we have. So you notice I have different windows here. So I have the console down here, which is where I actually put my code in and run it. But I mean, there's a lot of different windows, and I'm not going to explain all of these. We're going to just go into them as they're relevant. But you can see up here in the window above my console where I actually run my code, you can see the list of toy data sets that come with R is kind of built in right here, which is great, right? So we can look. I'm going to use one that should be familiar to you that we've done in the past, and it is called MT Cars. So let's see if I can find it in here. MT Cars. I know it's in here. Motor Trend Car Road Tests. So if I just type in MT Cars, it shows me the data set right here, right? So I have, unfortunately, so I need to make this wider so I can see, and then I'll run this again so I can see the whole setup on one line. So give me a moment here. All right. So my recording um, my recording elements are blocking this a little bit, but I just typed in MT cars on the command line. I hit enter. You can see I typed in MT cars, and it showed me this full data set. So these are all the different cars from Motor Trends, Car Road Tests, So I just typed in question mark and then empty cars. And you can see over here in my help window, a bunch of information about the data set popped up. You can see that. All right, so don't worry too much that you can't see the code that's popped up down here in the console. This just is question mark, empty cars. And again, it popped up the help frame. So don't worry about it too much because what I'm going to do is I'm going to actually put my code in R script so that I can have all my code. So when I run it directly in the console, it just kind of disappears and kind of goes away. It runs once and then it's kind of done. But if I actually start an R script and I have that right here, I can actually save the code that I ran. So again, these are the two pieces of code. I'm going to put my cursor right here, and then I'm going to basically hit Command Enter. It runs it, or you can just click Run over here. So now I'm going to run my next line, which is, so you can see my first line showed me the whole data set. Now I'm going to run my next line, which shows me that help file. So it's pretty useful. So I can look through and see what all these variables mean, which is really nice. And again, this is a toy data set. This is real data, but the idea is that you can toy around with it and kind of do some analyses and, hopefully learn something from it. That's the idea. So let's see, what's next? I want to see what are the names of the variables. So I can get the names here by looking at the whole data set. But sometimes I just want to, I just want to have them all listed in the console. Here's a list of all of the names right there in the console. Now I want to maybe run a regression so that I can maybe figure out, let's say I want to minimize MPG. So I want to make miles per gallon. I want to maximize it, excuse me. So I'm going to put a note here. I'm going to put this pound symbol or hashtag. Everything that follows it is like a note. So it doesn't run code. It's just commented out. So I want to write what my goal is. I want to maximize MPG. That makes sense, right? So like, what could we do? So, so these different cars, they all have different miles per gallon. Some have really high miles per gallon. Some have very low. Like you can see down there, the Honda Civic. And this is 1973 to 74. You can see the Honda Civic, even back then, got 30 miles per gallon. Toyota Corolla, 33. So some of these cars had pretty decent gas mileage. It's really surprising back then, but they did. And they were not popular back then, but then gas prices went way up, and then all these, high mileage cars became very popular. So I want to maximize MPG. So let's see, how do we do that? We have a bunch of predictor variables over here that could be the things, changing your gas mileage. Weight, that seems important, right? So let's see, let's just do a simple regression with so model one is where I'm going to save. So I'm going to run all this regression and I'm going to save my model, my regression model as model one. So let's see. So I'm setting up the regression. LM means linear model. I'm going to run a regression. I want to put as my outcome variable MPG. And then, I want to have my regression symbol there, which if you can see that it's a tilde, or it's like a squiggle type thing. It's called a tilde, but it's a wave that goes up and then down and then up again. Kind of like a smashed N. So that's going to be my regression symbol. So then I'm going to add in my predictor, which I think is weight. I think weight is going to determine this. And then I need to say what the data set actually is so that R knows what to run a regression on. So my data set is going to be empty cars. This data frame down here that you can see in the console window right now, that's my data set. So I'm going to go ahead and run that. I ran it. You can see there's not really any output, not yet, because on the account of the fact that um, I haven't like asked it to output it. I just asked it to run it. So now if I run Model 1 just by itself, it's kind of like show me what the output is. So then it shows me these regression outputs. So I have this coefficient, which is minus 5.344, and an intercept of 37.285. So what this tells me is if weight is zero, okay, so so this is kind of like a regression formula, like, right? Like, so y hat, which is mpg, equals intercept of 37.285 minus 5.344 times weight. So the intercept is kind of meaningless because this is saying if our weight was zero, then we should expect to get 37 miles per gallon. But the weight of zero is impossible. So the more important thing that we're really interested in is the coefficient there. So what this tells me is as I adjust the weight, what happens to the miles per gallon. So let's see, where's weight right here? So weight, this must be in tons or something, right? No, it says 1,000 pounds. So this is scaled to 1,000 pounds. So you have the Mazda RX-4 that's 2,620 pounds, right? You have the Cadillac Fleetwood 5,250 pounds. So for every 1,000 pounds that I increase in my weight, my miles per gallon goes down 5.344 miles per gallon. Okay. So you can see that's kind of my regression formula. So then now I know the impact that weight has on miles per gallon. Okay. So it's like I just said, let me see if I can make a formula right here. So y hat equals, and then I'll just, this will be the intercept. I'm going to abbreviate it because it's challenging to write with this pen. Plus, and then, of course, you have x, and then the coefficient right here, which is actually weight, but we'll call this b. Okay, so then you have weight, and then you have the intercept right here. And this is, of course, is miles per gallon, y hat is, so it could be, so if I was going to write it out with our actual data, it'd be like mpg hat equals 37 minus 5.3, and then instead of x, I'm going to put weight. So then we've added our actual values that we have to this regression formula. So here's our regression formula. So now I know what weight is going to do to my miles per gallon. You can see, if you calculate out this formula, obviously if weight is zero, 5.3 times zero, that's zero. So if weight is zero, then which is impossible, but if weight is zero, I should expect to get 37 miles per gallon. Now, if weight is 1, meaning weight is 1,000, it's scaled by thousands, right? So if weight is 1, then I'm expecting to get 37 minus 5.3, which is 31.7 miles per gallon. That's at a 1,000-pound car. If it's a 2,000-pound car, then I'm expecting to get 37 minus 10.6. And so you can see how it just keeps, as the weight increases, my miles per gallon keeps going down, 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 down. Okay? Does that make sense? Hopefully it makes sense. Hopefully I can erase this. Okay. I really need a bigger eraser. I'm going to put that on order here. I'm actually gonna put together something where I can kind of where I can kind of show you all of the, what all this output means and kind of diagram it all out for you. So expect that. So this is only part of the, this just shows only the coefficients, but actually a regression model, there's a lot more to it. So I'm going to show you the rest of the output from a regression model. So if I do like summary model one, and then I run it, again, that's command enter, or I can just click on the run button up here. This shows me the rest of the regression output. You can see that these two values, so the two estimates are the same as before. So you have your intercept of 37.285, and you have the weight coefficient being minus 5.344. But then you have some other values. So I'm going to take a minute to kind of explain these other values. So you have, so I'm not going to explain these into a lot of detail, but I'm just going to give you a quick overview, okay? So standard error, that gives me an idea of how much kind of variance there is around each of these values. So like if the standard error is really high, that means I can I don't have a lot of expectation that weight will really go down. The MPG will really go down by 5 as weight goes up. But you can see the standard error is pretty low. That means there's a low amount of variance and a low amount of noise. And actually, weight is a pretty clear signal and a clear predictor of miles per gallon, if that makes sense. So standard error, it just tells you kind of how reliable, how close of a shot group. So like I'll give you the example of like shooting, right? So if you're out shooting, you could be right on target, but you could have a broad, like your shot group could be very scattered, like all over the target and off the target. But on average, you're hitting dead center, right? So that would mean you would have you have a high standard error, you have a lot of variability, or you could have a very tight shot group where everything is kind of dead center or pretty close to dead center, and that would kind of be a low standard error. So then the t value, and here you have the t value and that probability, that's really the p value. So it says, I'm not really sure what this language says here, probability of that something is greater than the absolute value of t. But basically this is the p-value. So in statistics, p-value is usually the cutoff. It's calculated based on the t distribution. So the t-value is kind of what determines the p-value. So if you want, you can kind of just disregard the t-value and just look at the p-value and see if it is significant. In this case, significance is denoted by stars. So if the p-value is less than 0.05, so meaning it would have at least one star here, then we would say that that is significant. Meaning, and I'm going to try to explain p-values here. I'm sorry if I botch it, but I'm a marketing guy, not a statistician. But the way I understand p-values is a p-value tells you if you have a basically what I want you to take away is that if your p-value is higher than 0.05, then you could say there might be a difference. There is an estimate, there's a coefficient, there could be a difference, but it's not statistically significant, so it's not detectable. We haven't detected it in our data. But you can't rule out that there would be a difference. It's just saying we don't really have strong enough of a signal to detect that in our data. Let's see. So the residuals, let's not worry about that for now. We do have overall model statistics. So we can tell if the overall, not only if each coefficient and intercept is significant statistically, but we can also tell if the overall model is significant. So right here you have a p-value for that. And one thing that's really super useful is the r squared. So r squared here of 0.75 means that this our predictor explains 75% of the variation in miles per gallon. So 70. So if you tell me how much a car weighs, I can basically give you a 75% answer as far as like the miles per gallon, right? So the other 25% of the answer that I can't really explain, I don't know what's causing that. Could be like more efficiency in the engine or more aerodynamics or other things. But I can tell you if all you tell me is the weight of this car, I can tell you, I can basically give you a 75% solution in terms of like how much, what the miles per gallon is going to be. Okay. So that's what R squared is. So I've kind of gone through and explained all these different statistical um, numbers and metrics, and hopefully that makes sense. We're going to go into this more, and I am going to actually do kind of like print this out and do a diagram so that you can see what all these different things stand for. So hopefully that will help you. So let's see. The next thing I want to do is I want to do multiple variables. So nothing's really in isolation here. So I'm gonna put in another variable. Like I know weight really does matter, but let me look over here in the help document and I'm gonna look at all these other variables and see if they matter too. Number of cylinders, I don't know, displacement, that's the size of the engine, horsepower. I think horsepower, I'm gonna go with horsepower. That probably matters. I don't know that much about cars, but I'm thinking horsepower is important. So what I'm going to do is I'm going to do a plus and I'm going to add one more variable. So here we have weight plus h horsepower as predictors and run a new model. I'm just going to change this. This is going to be our new model, model 2, model 2, model 2. So I'm going to go ahead and run this. There's no output because it just basically saves the model. I'm going to skip this because this model just getting the output of the model isn't really helpful, but getting the summary of it has a lot more information. So I'm going to go ahead and just run that one. And I'm going to see, let's see. So both of these are significant. You can see weight is now minus 3.87, where before it was minus 5 something, I believe. It was minus 5.3. Now it's minus 3.8. And horsepower now has an impact and it's statistically significant. Okay. And also our R squared has gone up to 82.68%. So 0.8268. So now I can explain about 83% of what's going on. If you tell me horsepower and weight, I can basically give you an 83% solution in terms of what the miles per gallon is going to be. Okay. So I just by putting it in my formula. So remember you have your regression formula. You tell me, I take these coefficients right here. So let me write this out again. So MPG hat equals, first get our coefficient in there, 37 minus 3.9 times weight. And remember that's in 1,000 pounds. Let's see, minus 0.03 horsepower. Okay, so our expected miles per gallon is 37 minus 3.9 times the weight in 1,000 pounds minus 0.03 times horsepower. Okay, so that's gross horsepower, which Let me get my arrow back. Gross horsepower. So you can see horsepower ranges between 230 on the high end for the Chrysler Imperial down to 66 for this little Fiat. Actually 335 for the Maserati Bora. So you can see there's quite a variation. And, as horsepower goes up, miles per gallon goes down, but it doesn't have the same impact as weight, but here's the thing is scale, okay? So if we go back and look at this, let's consider the scale. So I'm just going to take a random car. I'm actually going to do the top one. So the Mazda RX, the weight is 2.6, right? 2.6, and the horsepower is what? 110. So if you consider, like, if you think about this algebraically, that, at first glance, weight has a much, much bigger impact than horsepower. 3.9 is much bigger than 0.03, right? But you have to consider the scale of these variables, because weight right here, 2.6, when you put 2.6 into this equation for weight and you put 110 in here for horsepower, you can see that the horsepower, because it's a totally different scale, so it actually is more impactful than you think. All right, let me go ahead and see if I can run this. So I'm going to do 37 minus 3.9 times 2.6 minus 0.03 times 110. So that's going to predict what our miles per gallon are. It's going to be like 82% predictive. So we'll run that and see what we get. Okay, I don't see it because it's blocked by that thing. I'm gonna run it again. Okay, so 23.56 is our expected miles per gallon. Now let's go back up and look at the actual table. 21, okay? So we expected 23.56 and we actually got 21 miles per gallon. So there are other variables at play that we don't know about. There's just random noise in the data. But this model, it's fairly predictive, right? We can figure out quite a bit just by putting our numbers in from our regression. So we have our, of course, we have our regression coefficients. So I'm going to go back down to regression again and just show you one more time just to be super clear. So you have your coefficient, which is 37. You have your weight coefficient, which is minus 3.9. And then you have your horsepower coefficient, which is minus 0.03. And then these two numbers right here, we put this in for horsepower, we put this in for weight. These are the actual values, like the predictive kind of values that we got from this Toyota. And then we just put it in there. I think it's like the RAV something or other. I can't remember, but these are the actual values. So we sub that in for weight and sub this one in for horsepower. And then that's how we got the 23.56, and we were a couple miles off. So our model's not perfectly predicted. That's expected MPG, but it's not like it's 100% predictive. Okay, so that's how that works. All right, so the next thing that we might want to do is maybe we could plot this out and just see how these variables end up. How they end up on this, how they track relative to this line. Actually, one thing I want to explain really quick. So you notice the coefficient for weight changed between our previous model that left out horsepower and our new model that includes horsepower. The reason why it changed is because there's actually a lot of overlap between the effect of weight on a car and the effect of horsepower on a car. And our model can't really tell necessarily which one is impacting miles per gallon. It's just saying what's correlated. So when you add two variables that are correlated to each other and correlated to the outcome, a lot of times these variables can kind of move a little bit and change, and they can even flip direction. So it's pretty crazy. But that's the reality of statistics, is like when you start including multiple variables in the model, things like move around because the model has to try to figure out how much impact one variable has versus the other. So it gets kind of tricky. So we're going to go ahead and graph out this data. So, all right. So first of all, I'm going to load. So this is a common thing that you do in R. You load a library. I'm going to load a library called ggplot. It says there is no package called ggplot, so I need to actually install it. Install.packages ggplot2, and then I'm going to run that. And so I can install this package that has like these powerful visualization tools. A lot of people have different preferences for different software, but most people agree that R has the best visualization software of any tool available anywhere. It's pretty like widely agreed upon. I've never heard anybody dispute that, I should say, but there may be other things out there I haven't heard of. So this is the visualization tool. So we want to use this and take advantage of it. You can see right now it's installing all the packages and the dependencies, all the things, all the components that it needs to make it work right. And it looks like I'm good. So I'm going to delete this. I'm not going to reinstall it again. That's a one-time thing. Now I'm going to run my library and make sure it's good. It looks like it ran just fine, so that's good. Now I'm going to do a little plot. I'm going to do a ggplot, and I'm going to do, I want to do a geom point, which means I'm going to plot all the points on a graph. Now I need to plot them based on both their y and their x axis. So I need to figure out what's going to be my y variable. Of course, y is going to be, so I'm going to add this AES kind of function here, and I'm going to say y equals mpg. So y is my outcome variable. Of course, that's going to be miles per gallon because that's what I want to maximize, right? So then my x is going to be weight. Okay, so what I'm going to come out with, and I of course need to tell it what my data set is. So of course this is still the empty cards data set. So what I hope that I'll be able to come out with is just all these dots plotted on a chart. You can see as weight goes up, 2,000, 3,000, 4,000, 5,000 pounds, miles per gallon plummets. You can kind of see, like you could eyeball a straight line going down, down, down between those, right? So it just kind of plummets. So I'm going to add a line. So if I do a geom smooth, this is going to add a regression line. So my regression coefficient that I just ran, minus 5.3, this is basically going to run the same thing right here and add this minus 5.3 regression. It also adds like this band around it that is kind of like shows you that it's more certain towards the middle, and then on the outer edges it's not as sure where this line might be because the band kind of gets wider. But you can basically see this is a minus 5.3 slope, which was our original regression coefficient for weight. So, so essentially we've just plotted this thing out, right? So next steps would be we don't have a lot of data here, but we could split it out if we were interested in another variable, like what are my other variables? Where's my help file? Cylinder might be important. So we can, this is spelled the English way, actually Australian way, because it's Australian made software. So I'm going to try to see if I can just put cylinder in there and get it to show me a different colors based on how many cylinders there are. So you can see it does this kind of gradient, which I don't really want because these are separate like categories. So I'm going to do, I'm gonna, I'm changing this variable right here to like a factor variable where it's not numerical continuous. It's just like categories essentially. And then I'm gonna see if I can run that again and get, oh, you can see you can see how the slope changes between 4, 6, and 8 cylinders. Um, and that's really pretty interesting to look at, I think. It's not super reliable because you have really low, especially with 6 cylinders. It looks like I have very few data points in there. But it's just interesting to look at. Like, wow, the relationship between weight and miles per gallon seems to depend on how many cylinders, to a certain extent, because you can see that slope, it changes direction a little bit based on how many cylinders you actually have. So when you have 8 cylinders, it flattens out quite a bit. So it's not as clear that weight has seems to have less of an impact on miles per gallon in the 8 cylinder world, if that makes sense. Whereas down here in the 4 cylinder world, the weight seems to have a big impact. Like obviously, the more you go down, the more you come across here. You start at 1,000 pounds, and you go up to, by the time you get up to 3,000 pounds, your miles per gallon has gone down significantly. Okay, so anyway, it's just interesting. So what we've done is we've basically gone through. We have a toy data set, which is actually a real data set, but for us it's a toy data set, which is this 1974 Motor Trend US magazine car statistics. We've put it in our regression model. We've plotted it out, and we now have a much stronger understanding of the relationship between weight and miles per gallon. Again, I've gone through this early in the semester, so a lot of this should seem like review to you. And if it does, that's great. But this is where I want to go ahead and get started. And that's all I have for today. So thanks for watching, and let me know if you have any questions or anything.